Simple inequalities. An equality is a mathematical relationship indicating that the quantities or expressions on the left side of an equation have the same value as the quantities or expressions on the right side. The equality symbol is the equal sign. An inequality is a mathematical relationship indicating that the quantities or expressions on the left side of an equation do not have the same value as the quantities or expressions on the right side. An inequality also shows the relationship of the quantities on either side of the equation. Let A be the quantity on the left side of the equation and B the quantity on the right side. A is not equal to B. A is greater than B. A is greater than or equal to B. A is less than B. And A is less than or equal to B. Inequalities can be read in either direction, as long as the correct vocabulary for the symbol is used. Often when solving problems for a variable, it may be on either side of the symbol. For example, we can read this as 15 is less than x, or x is greater than 15. Here we have 7 is greater than or equal to x, or x is less than or equal to 7. Here we would read this as x is not equal to 5, or 5 is not equal to x. Part of mathematics is translating word problems, situations, or equations into mathematical expressions. For example, in order to translate this situation into an expression, 3 times the number n is less than 210. We're going to start on the left side of the expression by realizing that 3 times the number n is 3n. Then the right side, where this quantity is less than 210, so we're going to use the less than symbol. Putting them together results in 3n is less than 210. Write an inequality for the following sentence. The sum of a number n and 15 is greater than or equal to 9. So the left side of the expression is n plus 15. Since n plus 15 is greater than or equal to 9, we will use the greater than or equal to symbol, resulting in n plus 15 is greater than or equal to 9. Write an inequality for each of the following sentences. The product of a number n and 7, so that would be 7 times n, is greater than or equal to 9. 5 less than a number n, so that's n minus 5, is greater than 10. 10 more than a number x, so that's x plus 10, is less than or equal to 20. Twice a number y, so that's 2 times y, is less than or equal to 9. And here are all of the solutions. A number line is used to visualize a solution set. A solution set includes all the numbers that satisfy an equation or inequality. The graph of that solution set on the number line indicates all the members of the solution set. A closed circle, or a filled-in circle, means that the number is in the solution set. For instance, the solution set for the equality x equals 2 is shown on the number line as a closed circle on the number 2, which means 2 is the only solution to that equation. An open circle means that a number is not in the solution set. This graph shows that 2 is not part of the solution set, for x is not equal to 2. But there are many numbers that are part of the solution set x is not equal to 2. All the numbers except 2. Since a line or array is made up of an infinite number of points, the rest of the solution set is shown by rays extending from 2 to positive and negative infinity. The open circle at 2 makes it clear that the only number not in the solution set of x is not equal to 2 is the number 2. Applying that same approach to the inequality x is greater than 2 results in an open circle on 2 and a ray extending from 2 to positive infinity. The open circle makes it clear that 2 is not part of the solution set, since 2 is not greater than itself. The ray extending to positive infinity makes it clear that all the points greater than 2 are part of the solution set. The lack of a ray pointing towards negative infinity shows that no points less than 2 are part of the solution set. Applying that same approach to the inequality x is less than 2 results in an open circle on 2 and array extending from 2 to negative infinity. The open circle makes it clear that 2 is not part of the solution set, since 2 is not less than itself. The array extending to negative infinity makes it clear that all the points less than 2 are part of the solution set. The lack of array pointing to positive infinity shows that no points greater than 2 are part of the solution set. The inequality x is greater than or equal to 2 includes 2 in its solution set, so the circle on 2 is filled in. That is called a closed circle. The graph for x is greater than or equal to 2 combines the graph for x equals 2 and the graph for x is greater than 2. And the description of the symbol combines greater than and equal to. They are combined by the word or, since the solution set includes all of the points that satisfy either requirement. The inequality x is less than or equal to 2 includes 2 in its solution set, so the circle on 2 is filled in. The graph for x is less than or equal to 2 combines the graph for x equals 2 and the graph for x is less than 2. And the description of the symbol combines less than and equal to. They are combined by the word or, since the solution set includes all the points that satisfy either requirement. Write an inequality in terms of x corresponding to this graph. Well, x can be -4 since it's a closed circle, or any number larger than that, more positive than that. So x is greater than or equal to -4. The array extending to the right denotes that all values greater than -4 are solutions, while the filled-in circle indicates that -4 is also part of the solution set. Write an inequality in terms of x corresponding to each graph. Right, so this one is that x could be equal to -4 or any number greater. So x is greater than or equal to -4. For this one, we have an open circle, so we don't have the equal to option. X is going to be less than 6. Here, x is equal to any number that's not -6. So x does not equal -6. And here are all of the solutions.